Assalamu alaikum warahmatullahi wabarakatuh. Okay, we'll start meeting now. We have to discuss the problems based on spectroscopy today. How you have to solve the problems based on the spectroscopy. That we have to discuss. Okay, are you able to listen me? Yes. Are you able to listen me? Okay. Now consider. Yes. Okay. Thanks. Therapy. This DBE, consider a compound with general formula C6Hy. It is not, you are not able to see here, C6Hy. Then if compound is there, then first your job is to find out the number of unsaturations in that compound. That is also called as number of unsaturation, NUS, or double bond equivalent. You are able to see here C6Hy. C6Hy is here. Okay. Now that is calculated by the formula double bond equivalence, or number of double bonds, or number of equivalence, number of unsaturation, NUS, in this way. X, that is the number of carbon atoms, plus 1, okay, minus Y upon 2. What is Y here? Y is the number of hydrogen atoms divided by 2. Okay. Number of unsaturation is equal to number X plus 1 minus Y upon 2. X is the number of carbon atoms, okay, and Y is the number of hydrogen atoms. Consider this formula C6H6. Consider the compound with molecular formula C6H6. Then 6 plus 1 is equal to 7, minus 6 upon 2 is equal to 4. So 4 number of unsaturations are there. C6H6, 4 unsaturations may be there. So for 4 unsaturation, such type of one benzene ring may be, we may consider one of the benzene ring. Three double bonds and one benzene ring. One benzene ring is considered as one unsaturation. Okay, these are three double bonds. Three double bonds plus one benzene ring. So it corresponds to 4. 4 number of unsaturation. Okay, you should keep in mind benzene ring whole is considered as one ring. It is considered as one double bond. Okay, so 3 double bonds plus one ring, that is equal to 4 unsaturations are there. C6H6 benzene. Okay, alternative, you may think of the 4 unsaturation, so type of formula may be there. CH2 double bond CH. See, this triple bond is again, it is considered 2 double bonds and 1 triple bond. 2 double bonds here, 2 double bonds, okay, 2, and 1 triple bond, it is equal to 2 double bonds. Okay, in this way 4 unsaturations are there. 2 double bonds, okay, 2 unsaturation, and this 3 triply covalent bond, it is equal to 2 double bonds. So number of double bonds will be 4 here. Now 4 unsaturation. Now how to identify that triple bond? A triple bond may be regarded as equivalent to 2 double bonds. The presence of triple bond, C triple bond and cyanide or alkyne may be easily recognized by the infrared spectroscopy. Some particular values are there. With the help of those values, you can understand whether triple bond is there or not. Okay, with the help of IR spectroscopy, some values I will give later on. That values will indicate you whether the C double bond, C triple bond, or C cyanide bond is there or not. So if the compound contains one or more divalent atoms like sulfur, oxygen, etc., in the addition to elements like carbon and hydrogen, the presence of divalent atoms can be ignored while calculating the double bond equivalence. Okay, if along with carbon and hydrogen, some oxygen, some sulfur, etc., atoms are there, then they should not be taken into account. We have to take into account, we have to consider the presence of carbon and hydrogen only. You should not bother about the number of oxygen, how many number of oxygen atoms are there or not. You should not care about them. We have to concentrate only two things on carbon and hydrogen. So okay, if the compound contains divalent atoms like sulfur, oxygen, then they should be not be counted. They should be ignored while calculating the number of unsaturations. Now find out the double bond or ring equivalence for the compound with molecular formula C3H8O3. Okay, so let us calculate double bond equivalence here now. Now 3 plus 1, 4, then 8 upon 2 is equal to 4. So 3 plus 1, 4, minus 8 upon 2, 4. So number of equivalents will be 0. No double bonds in the this compound. Compound will be saturated. Okay, oxygen should not be bothered here. It should not be taken into account while calculating the number of unsaturation. Now you calculate the number of unsaturation for this compound C6H6. You keep all the things with you, a notebook. You calculate the number of double bonds or number of unsaturation for this compound C6H6. You have to calculate in further examples also. Today's session is specially allotted for the calculations of the numericals. All should try. All the members who are joining the meeting, they should try. It is not too much difficult. Simple job is there. Okay, you calculate. Anybody calculate? Formula is before you, x plus 1 y upon 2. You are requiring much more time. It should not require so much time. See here, just like we have calculated here or here, 3 plus 1, okay, 3 hydrogen atoms are, carbon atoms are there, plus 1, x plus 1, 4, minus number of hydrogen atoms, 8 by 2. Now 3 plus 1, 4 upon 8 upon 2, 4. 4 minus 4 is equal to 0. In this way, you have to calculate. You take pen and calculate. No, it is not necessary to have pen with you. You may also calculate by simple arithmetics, simple logic you can keep in the mind, and you may calculate. I think you have not got something. Something is missing. Okay, I will explain once more. To calculate the molecular, this is the molecular formula of the compound C6CXHY. Now how to calculate the number of equivalence, double bond equivalence, or number of unsaturation in the compound. Now how to calculate X plus 1? X is the number of carbon atoms plus 1 minus Y upon 2. Y means number of hydrogen atoms. So C6H6 formula is given here. C6H6. Now 6 plus 1, 7 minus 6 upon 2 is equal to 4. Okay. Now 4 number of unsaturations are there, 4 double bonds they are possible here. Now 4 double bond means such type of structure may be possible for 4 double bonds. Number of unsaturation are 4. So 3 double bonds and 1 ring. 1 ring correspond to 1 unsaturation here. So therefore these are the three double bonds, 3 plus 1 ring. Okay. The next 2 double bonds and 1 triple bond. Next possible arrangement is that if it is aromatic, then it is well. If it is aliphatic, then such type of arrangement may be possible. 2 double bonds and 1 triple bond. 2 double bonds, 2 unsaturation, 1 triple bond, it is equal to 2 unsaturations. Okay. So 4 unsaturations are there. A triple bond may be regarded as equivalent to 2 double bonds. The presence of triple bond may be easily recognized with the help of IR values. IR values are there which indicate the presence of double bond there. Okay. So if the compound contains sulfur, oxygen, such type of divalent atoms, then addition of the elements in addition to carbon and hydrogen, the presence of divalent atoms can be ignored. They should not be taken into account while calculating the number of unsaturations. Same formula it is applicable as here we have calculated this. Similarly, we will go for this. Okay. Now find the double bonds or ring equivalents for the compound with molecular formula C3H8O3. C3H8O3. Now 3 plus 1, 4 minus 8 upon 2. 3 plus 1, 4. 8 minus 2, 4. So 4 minus 4 is equal to 0. Now you calculate the number of double bonds for the molecular formula C6H6O2. Okay, you proceed once again. You calculate the number of unsaturations or double bond equivalence or number of unsaturation in the compound for this formula. You have to calculate. If you have to propose the structure of the compound, then you have to calculate that. You calculate. No one is able to calculate. Okay. 4 4. Okay. Okay. Very good. This is 6 minus 6 upon 2. 6 plus 1, 7 minus 6 upon 2, 3. Okay. So 7 minus 3 is equal to 4. Okay. Now we have to solve this problem. Uh, take propose a structure consistent with HNMR date data of each of the following compound. C3 C3H6O. Okay, you calculate number of unsaturations here first, then we'll proceed further. C3H6O. One is correct. One is correct here. You see, 3 plus 1, 4. Okay, minus 6 upon 2, 3. 3 plus 1 is equal to 4 minus 6 upon 2. So 4 minus 3 is equal to 1. Okay. Now delta value is 2.05 and it is a singlet having 6 hydrogen atoms. 6 hydrogens of one type. Then what may be the structure of the compound? Yes. What may be the structure of the compound? One unsaturation is there and there are 6 hydrogen atoms of one type only, and this value is delta value is 2.05. Now you see here 6 minus, sorry, 6 plus 1 minus 6 by 2 is equal to 1. Okay, one unsaturation is there. Now one unsaturation is there. Now 6 hydrogen atoms are there. They are of one type only. So what will be the structure? Possible structure may be CH3 CO. CH3. Sorry. Okay. So possible structure number of, first you go for number of calculation of number of unsaturation or double bond equivalence. So once this job is over, you consider the next point as the six hydrogen atoms are there. Now there are six hydrogen atoms. One unsaturation C double bond O. Okay. Now there are two hydrogen atoms. Uh, six hydrogen atoms are there of only one type, and it is showing singlet. S means singlet. Okay. I have told you the value of acetone is near 2.1, so it is 2.05. Okay, in this way, you remember always if there are six hydrogen, these are the six hydrogen atoms of one type. Singlet is obtained here because they have no chance to couple here. Why singlet is obtained? No chance to couple here. Okay, because this carbon is not having hydrogen, so they cannot couple here. Okay, come to next. C5H10O. Okay, now you calculate the number of unsaturations here. C5H10O. C5H10O. You calculate the number of unsaturations here. Simple job is there, not requiring too much time. Why you are requiring so much time for calculating only unsaturations? C5H10O. Okay, almost three students they have solved the problems. Very good. One unsaturation is there. 5 plus 1, 6 minus 10 upon 2 is equal to 5. Okay, means this compound is having one unsaturation. One unsaturation, one more answer. Okay. So one unsaturation is there. And now there are six hydrogen atoms having a triplet. Triplet means, what do you mean by this triplet? ट्रिपलेट का क्या मतलब होता है? बाजू के कार्बन, हाउ मेनी हाइड्रोजन एटम्स दे आर अटैच्ड टू द एडजेसेंट कार्बन? यस, व्हाट डू यू मीन? If this carbon atom it is getting triplet, then how many hydrogen atoms they are attached to the adjacent carbon atom? Yes. Oh, okay, very good. Means two hydrogen atoms they are attached. Means two hydrogen atoms they are attached. Okay. You may consider one unsaturation here. One unsaturation is there. Okay. One unsaturation. Then what we are telling? Data is telling you there is a triplet having, there is a triplet. Triplet means adjacent carbon atom it has two hydrogen atoms. Okay. Now six hydrogen atoms are there. So CH3 here, CH2, sorry, CH3. Okay. Now CH3, CH2, CO, CH2, CH3. Now there is a triplet having six hydrogen atoms. This there are six hydrogen atoms. Okay, of one type only. They are showing triplet here. Okay, triplet. Triplet means there are two hydrogen atoms attached to it. So it is showing triplet. This is triplet having six hydrogen atoms. What is remaining? Four hydrogen atoms. These are the four hydrogen atoms. Okay, four hydrogen atoms. They are showing quartet. Quartet means three hydrogen atoms they are attached to the adjacent carbon atoms. Okay. Okay. Well, we have solved both the problems now. Now let us uh, work together for this problem. Propose the structure of the formula having the following with two PMR signals. Now I have to calculate the number of unsaturations here. C8H10. Now how many unsaturations are there? Okay, four. Four unsaturations are there, isn't it? Now, what we want the structure which should give two PMR signals. We require two PMR signals. Okay, four unsaturations should be there, and it should show two PMR signals. So Possible structure 8 plus 1, 4 unsaturations. Now, how we have calculated 2? 8 plus 1, 9, minus 10 upon 2. 9 minus 5 is equal to 4. 4 number of unsaturations are there. And what we want? 2 PMR signals. Molecular formula is C8H10. Okay. Now this is the benzene ring and CH3 attached to this. This is 1,4-dimethyl benzene. Okay. Or we may call it as no. Okay. 1,4-dimethyl benzene. It will show uh, two, what do I say, signals, two PMR signals they will be obtained for this. Okay. How you will get two PMR signals now? One signal it will be for two CH3 groups. Okay. CH3 groups having, this will be of course singlet. Singlet having 6 hydrogen atoms. Okay. Singlet having 6 hydrogen atoms. And there are 4 hydrogen atoms. There are 4 hydrogen atoms. They are of one type. So it's a type of two signals they will be obtained. 4 hydrogens are of one type. This will also be singlet. Singlet having 4 hydrogen atoms and singlet having 6 hydrogen atoms. Okay. Now let us proceed further. Now C4H10O. Okay. Number of unsaturation 4 minus 4 plus 1, 5, 10 upon 2, 5. So 5 minus 5 is equal to 0. Okay. No unsaturations are there. So possible structure may be this diethyl ether. Okay. One signal. How you will get one signal? Two hydrogen at 4 hydrogen atoms. Okay. And for 6 hydrogen atoms. Two signals they will be obtained. This will be triplet. Okay. This will be triplet having 6 hydrogen atoms. 6 hydrogen atoms, triplet. Then 4 hydrogen atoms, they will be quartet. Quartet having 4 hydrogen atoms. These are the 4. Okay, you are getting or not? No unsaturation, so 0. So centrally we take oxygen atom, then CH2, CH2, CH3, diethyl ether. Okay. Now let us proceed further. C10H8. Now you calculate the number of unsaturations for C10H8. Okay, 7. Okay, 7 unsaturations are there. And what do we want? 2 PMR signals. Then what is the possibility? Okay, 7. Fine. Very good. Now, what is the possibility? This is the possibility of this structure. C10 H8. 7 unsaturations. Okay. 3 unsaturations. 3 plus 2, 5. Okay. 5 and 2 rings are there. 2 rings are there. 1, 2, 3, 4, 5, and 2 rings is it, 2 ring correspond to 2 unsaturations. So total number of unsaturations will be 10. Sorry, 7. Okay. Now you see here how it will show two types of we are speaking about the PMR signals. Now it will show two PMR signals. How? One signal due to 1, 2, 3, 4. These are the 4 hydrogen atoms are of one type. Okay, 1, 2, 3, 4. Numbering is numbering may be different, but I am telling you that I am showing, I am counting the number 1, 2, and these 3, 4. These are of one type. Okay, and this 1, 2, 3, 4. These are of one type. Different type. Two signals we will obtain here. These 4 hydrogen atoms are of one type, and these 1, 2, 3, 4. These 4 hydrogens of one type. Okay. In this way, this is what is the name of compound here? Yes. What is the name of compound?